All right, I think we're ready to go here. So today we're going to get into, like I said, inverses of functions. You guys did talk a bit about this in Algebra 2, so I'm just curious, anybody remember anything about what an inverse is? Yes?
Don't you switch the x and y and solve for x?
Solve for y. Yeah, so you would, so if you have some kind of an equation, like let's say y equals 2x plus 3, the inverse of that would be x and y switching roles. Okay, so the x becomes y and the y becomes x. So the inverse would be x equals 2y plus 3. Okay, now usually we want to write these as a function. Okay, so the only reason that we would solve for y is if we're interested in the inverse function. The inverse relation is actually right there. And we could just leave it, and it's fine. It just shows, a relation is just showing a relationship between x and y, which this equation does, right? Shows a relationship between them. It shows how one's equal to the other. But it's not a function, okay? So if a relation is a function, we should be able to solve it for y and then write it in function notation. So if that was my goal, the inverse function, okay, then I would take that, solve it for y. So I would have, let's see, y equals, I have to subtract 3 divided by 2, so x minus 3 divided by 2. Okay, but this relationship here is really the same as this one. I've just, moved things around using algebra. Okay, but what I've done here, though, is because I can solve it for y, I've proven that that original equation that I wrote down, this original function, because it's solved for y, does have an inverse that is a function. And that's not always the case, though. Okay, so if we start taking a look at some other functions, sometimes we're going to run into problems when we try to do this process. We try to find the inverse. So, and I'll write this one in function notation to begin with even. So let's say I've got f of x equals x squared plus 3. Okay, and I would like to see if the inverse relation to this is indeed a function or not. So, to actually go through the process of doing that, remember f of x is really just a fancy way of writing y if it is a function. So what I would usually do is just take this thing and then change it into this, y equals x squared plus 3, and then do what we just did with the last one. To do the inverse, x and y switch roles. So we just change them. Oops. So my inverse then is x equals y squared plus 3. So that is the, like we said before, the inverse relation. Okay? So if we want to check to see if it's a function, we got to try and solve this thing for y. Okay? So first step, I would subtract 3. X minus 3 equals y squared. And then what? What would be the last step to solving this? Square root. Now, we've got to be careful though. If I use a square root to solve an equation, I technically have to use what? Plus or minus the square root. Yeah. So what I have here then, and I'll just switch the y onto the other side, but it's plus or minus the square root of x minus 3. Is that a function?
I was going to say, wouldn't you have to also be plus or minus y?
No, you don't. Because it would just kind of cancel out, technically. Because you would have plus or minus the square root of y squared. But if you had a plus or minus equals a plus or minus, it's kind of a long story, but you could divide by negative 1 on either side to get rid of the minus, and then divide by positive 1 on either side to get rid of the plus, and you'd end up with still a plus or minus on the other side. It's kind of confusing, but I can explain it more later if you want. But Yeah, technically, just long story short, you don't need to do it. Just on one side of it, and it's fine. So I guess as well here then. Is that a function? It's plus or minus the square root of x minus 3. Remember, a function, for every one input, you have one output. Does this have one output? You'd end up with two answers, right? You got to use the plus and you got to use the minus. There's two. You get two answers for every one input. Okay? So this is not a function. So this original function, it has an inverse, but the inverse is not a function itself. Okay? So basically what this is telling us is inverse is not okay. So we're going to switch gears here just a little bit, and we're going to go and look at inverses from the graphical side of things. Okay? So this is kind of the way of going about it. Okay? If you have a function or if you have an equation you want its inverse, you just switch x and y and solve and all that. How does it work on a graph? Well, there's a relationship between the two, the original function and its inverse when you put it on a graph. Alright, so let's just take some ordered pairs to begin with. And let's see if you guys can use that to either discover or remember what the relationship is on a graph. Okay? So I'm going to do my original function, or my original relationship, I guess, because it's not necessarily going to be a function. But I'm going to do one in one color and the other in another color and see if you can pick out what's going on here. Alright, so let's start with so let's say we've got 2, 2 is A. 2, negative 3 is B. 1, 0 is C. And negative 2, negative 3 is D. And maybe one more. Negative 1, 2 is E. Okay, so somebody remind me here again. What do you do when you make an inverse? What were we doing with the equations when we did that inverse step? You switched x and y. Okay, so if I have a bunch of ordered pairs and I want their inverses, what am I going to do to them? Okay, so you're one step ahead of me. So we're going to switch x and y, and then we're going to see that, what you just said. Okay, so if we, for each one of them, think about what the coordinates are, okay, and we're just going to swap them then, okay? So what are the coordinates of A? 2, 2. So if I swap x and y, what are the coordinates of its inverse? Still 2, 2, right? So the inverse of A is in the same spot. So it's kind of right on top of itself. And we're going to put little primes for each of the inverses. So we'll say that, so there's A prime, there's the inverse of A. Okay, what about B? We're at 2, negative 3. So what should be the inverse of that? Negative 3, 2. Okay. So negative 3 up 2. And that's going to be B prime. Oh, I totally screwed up my scale over here. Did anybody else catch that? Yeah, sorry. We'll assume there's a negative 1 in there somewhere. C, we got 1, 0, so the inverse should be 0, 1. So that's going to be here. D was, let's see, negative 3, negative 2, so that's going to be negative 2, negative 3. So that's going to be down here. And then E, we had -1, 2, so that's going to be 2, -1. So 2, -1, I guess, will be somewhere like right there then. Okay, so maybe it's not clear by looking at that right now. This line right here. Okay, each of those points is a reflection, except for like this D prime because I screwed up my scale, but you just ignore that one. The rest of them look pretty good though. Each one you can see is just a direct line, okay, because the X's and the Y's are changing. So the A, it makes sense, it's right on top because that lands right on that line of reflection. C is reflected over it. E is reflected over it. B is reflected over it, okay? So with functions, remember a function or a graph of an equation, it's just a big clump of points, right? So you're going to do this same kind of process.